Hello? Yes. So welcome to the talk, Data Engineering with Cloudera Altus. I'm a product manager at Cloudera, and I focus on cloud technologies and on data engineering. So who Cloudera is, we are a distributor of the Apache open source data processing stack. We have a distribution called Cloudera Distribution of Hadoop, which we nickname CDH. We have 24 different components in this particular distribution, and we have committers across the entire stack. What Cloudera Altus is a new platform as a service offering that we have that is streamlined for particular use cases in big data processing. The data engineering is our first targeted use case for Cloudera Altus. It is backed by the standard CDH, Cloudera distribution, and we are managing clusters in this platform as a service so that we focus on end user workflows. From a very high level, why Cloudera Altus? We manage clusters so that you no longer need to administer CDH clusters in the cloud. And we use compatible versions of the CDH distribution. So if you're using Cloudera on-premise or in a different cloud than AWS, then we would be using the same distribution across different cloud providers as well as on-premise. This allows for easy workload migration across all of these different platforms. We focus on enterprise use cases, so we've had many years of the CDH distribution released on on-premise environments for all types of verticals, and so we want to bring all of the enterprise capability that we provide for on-premise Cloudera distribution into the cloud, and we want to make it very easy for you to migrate your workloads within your on-premise and across different cloud providers. So first, I want to discuss a little bit about the data engineering use cases that we're targeting. The CDH platform has 4 different types of workload patterns that we expose to end users. So this is data engineering, where you're taking raw data and doing data transformations on this raw data into cleaned tabular formats for further analytics or visualization or reporting. The second one is data science, where you're doing things like forecasting, creating models with data science libraries, and then creating models and doing different types of forecasting for your end user. There's Analytic DB, which is SQL-based type of ad hoc queries, as well as visualizations of that data, and then real-time streaming and analytics using our operational database. So 4 different workload patterns within our CDH distribution, and today we're focusing on the data engineering portion. So kind of recapping, where does data engineering take place in these 4 different workload patterns? And this is the data engineering is the standard ETL transformations when you're ingesting all of the data and then you're converting this into nice clean data. In the machine learning pipeline in particular, this clean data is given to the data scientist. The data scientist starts creating machine learning models from this cleaned up data, and then once they have validated machine learning models, this workflow is given back to the data engineer typically so that you can run new data on these validated models and be able to do things like predictive analytics. So in this last step of data engineering, it's often a data engineer who is doing this operationalized recurring workflow with the validated models. Sometimes it's the IT admin, sometimes it's the data scientists themselves. In terms of where cloud actually plays in this whole sort of high-level workflow, we see customers using cloud in different ways in terms of leveraging cloud infrastructure capacity. So from a high level, you're ingesting data from multiple different types of data sources. You're processing this data into clean data, and then you want to deliver insights through some form of analytics and then make business decisions. In terms of where people start using cloud, many times people want to do the process and transformation of this raw data into clean data in the cloud because you have infrastructure as a service and you can get compute capacity very easily in order to do this processing. So lots of people put this particular step in the cloud and have everything else on premise. Other customers have all of the data ingested into the cloud to begin with. And so instead of taking all of this data, this raw data down into on-prem and doing the data transformations, they do all of the data transformations in the cloud and then take the aggregate and bring it back onto on-premise and do the visualizations and applications on-premise. And yet others will go into the cloud and basically do all of the steps in the cloud because they either have started applications in the cloud or they have directives to move all of their on-prem clusters into the cloud. And one last workload pattern that we've actually seen is that there are workflows that go on the cloud and workflows that go on-premise. Some customers are not comfortable with having all of their data in the cloud, and so they'll separate their different types of data analytic workflows and put sensitive data in the cloud, sensitive data on-premise, such as PII data, and then they'll have other less sensitive data in the cloud, and they'll have full workflows with the different types of data that they're serving in different infrastructures. So the goals of the data engineering and IT are stated here in terms of trying to actually get through those data pipelines which do these data transformations. So for the data engineer who is actually trying to ingest and process all of this data, what they care about is that they can reliably do this on a particular SLA. So their downstream stakeholders need all of this data at some repeated period of time. It might be on a 24-hour basis, it might be on a weekly basis where they have newly ingested clean data. It might be more on a continuous manner, but they need to meet an SLA, they want to do it reliably and somewhat cost effectively. There's an ease of use component in which they need to get capacity in order to process this data, and they have two different types of workflows. They have a development workflow in which they're creating these data pipelines, and they need an interactive experience so that they can create the applications that are going to run all of these data transformations, and they need tools in order to be able to troubleshoot at these interactive workflows. And then there's the production environment where they've operationalized all of this data engineering pipeline so that they can recurringly run this pipeline to clean data as it's continuously getting ingested from all of these external different types of data stores. The IT administrator is also interested in getting a very efficient data pipeline working, so they're interested in having the minimal cost associated with running all of this capacity. They're concerned about different types of security. Is the security in the cloud sufficient for the data and for all of the control plane? They want standardization, so they prefer to use a single vendor for on-premise cloud and across different clouds because they don't want to use different distributions and go to different vendors in order to support this whole process. And they also want agility for their end users so that they are not the bottleneck in terms of bringing these business insights to their company. And so in order to achieve these objectives, a lot of companies are saying that they want to take all of the public cloud properties, which is hyperscale data storage that has durability and high availability, and also infrastructure as a service, a self-service compute capacity, and meet their different IT and data engineering goals of agility and ease of use and cost. And so what we're doing with Cloudera Altus is basically bridging this gap between the cloud native capabilities that you get with infrastructure as a service and hyperscale cloud storage and all of the needs that are involved with the data engineering as an experience. So one of the things that large steps that we've taken is in the ease of use category. And so we have taken a very large step in terms of ease of use by offering a managed service. What this means is that there's now a portal that you can go to. This is actually the URL. And this is a portal that you can go to where you can see all of your jobs and your clusters that are running. And these clusters are managed by the Altus product itself. And when you need to spin up a cluster or you need to execute a job, you would either execute it against the UI for this console, or you would go to the API or the CLI that is a wrapper around the API. We are a API-first product, so everything that you can see here in the UI is actually using the Altus APIs. So with Altus, this means you don't have to do a lot of the operational management capabilities that you had to before with a CDH cluster. This means that there's no downloadable software that you have to install. There's no worry about cluster configuration. We do intelligent default configurations for all of the various instance types that we support. You don't have to upgrade your CDH cluster. If you want to have a new version of CDH, you simply terminate this cluster and then start another cluster with a new version. There's no OS patching or upgrading. We handle all of that in the back end. We manage basically the binaries and the images. You don't have to SSH into the cluster anymore. So you don't have to SSH into edge nodes or into master nodes in order to submit jobs. You would submit directly into our console or our API. So what does this mean? This means that if you don't have to manage the cluster anymore or do all of the configuration of the cluster, it becomes a very end-user focused type of a product, right? So we have jobs and workloads as first-class objects within our system. So you can do things like you can create jobs and submit jobs, clone jobs, terminate jobs, troubleshoot jobs, and we're trying to make all of the workflow that's associated with these jobs and workloads very easy for the end user. This means that clusters now become supporting objects within the system so that they're there in order for you to spin up capacity, but the knobs are very few, and we've done a lot of intelligent defaults, and you don't have to manage operationally all of these things about the cluster. And since the data is typically resident in your hyperscale cloud storage, which is external and persistent, you can terminate the cluster when you want because the state of the data is not within the cluster itself. So in terms of agility, we, again, deliver basically the CDH distribution, which is the enterprise distribution that we use on premise. This is the same distribution that backs Cloudera Altus, and therefore you can migrate workloads very simply from one data center and infrastructure to another. And this really lowers your risk in terms of starting your migrations into the cloud or trying to use multi-cloud types of environments. We do have all open source core components. All of our optimizations that we have for the cloud infrastructure have been checked in upstream. And so we don't want to provide any kind of vendor lock-in on the data plane layer. We also don't want vendor lock-in in terms of cloud service providers. We leverage cloud native infrastructure where possible. This means we decouple compute and storage when using Cloudera Altus for data engineering. So all of your compute, we assume, and we optimize for the path where all of your data is in AWS S3. So we support AWS S3 today. Directionally, we will be supporting Azure as well with Azure Data Lake. So we are actively working on that. But today we support AWS, and so the hyperscale cloud storage we support is S3. And you would ingest data into S3 as your data is coming in from your multiple different types of endpoints, and then you would spin up compute capacity as needed to meet your SLAs in order to process all of this data. So we assume that there's a decoupling of your compute and your storage, and this allows you to size your compute for whatever you need to process the size of data that you need to meet your particular SLA. When you're not using your cluster, you can terminate your cluster. So you would spin up your cluster when you need. You would process the data and terminate the cluster. There's also a single API call that allows you to do this entire step as well. And the reason you would terminate your cluster is so that you're not paying for compute capacity when you don't need it. Because you are using this specifically for data engineering workflows and not mixing different types of workflows, you now have, as a result, compartmentalized performance. So you don't have to worry about data engineering compute capacity that is needed for some bursted period of time interfering with your ad hoc queries in your BI analytics, because now you have specialized clusters for each of your different types of workload patterns. Okay, so one of the things that we wanted to make sure was very easy as we started to move into this platform as a service model for our data pipelines was that we supported the full workflow of a unified platform across the data pipeline. So Cloudera Altus supports data engineering clusters today, but the data engineering cluster should work seamlessly with other specialized clusters in the Cloudera stack, regardless of how those clusters are deployed. So what we want is basically no data silos. If you have a data lake in AWS S3, we don't want this to be siloed based on which clusters you're using to spin up these clusters, or based on the type of workloads they're actually using. We want to have a data lake that's consistently managed in terms of security and metadata and everything else. So we don't want any data silos. And this means that all of the metadata that's associated with the data that's resident in S3 has to be shared across all of these different clusters. So we are doing a number of things to ensure that all of the metadata is consistent across these different clusters, regardless of how the clusters are deployed, through managed services, through Cloudera Direct, or through basically CloudFormation templates. So in terms of data consistency, S3 is an eventually consistent system. It's not a strongly consistent system. That means that you may not have consistent view of this data when you put data into S3. There is an upstream work that has been done on S3 Guard. It's joint work that was done by Cloudera, Hortonworks, and Western Digital in order to offer a consistent view of data in S3. So if you have multiple clusters that are operating on the same data store within AWS S3, these different clusters have to share the same view of that data. And S3 Guard is the product that we're using, or the feature set that we're using in order to have a consistent view. And this view of consistency is shared across clusters. So if you have a pipeline that's doing data engineering in sequential steps across different clusters and then dumping into a BI analytics like a data mart that's backed by Impala, all of these clusters can share the same consistent view using this feature. There's metadata consistency that needs to be shared across the different clusters. So we have different types of metadata that's associated with the data. These are things like Hive Metastore schema and Impala statistics, Navigator lineage information, as well as the S3 Guard metadata. And so we're making sure that all of this metadata is consistent across different clusters that are being used. In Cloudera Altus, for simple scenarios, like if you are actually creating a cluster to read data off of S3, you can create tables inline in your script and just create the tables because they're in a script typically that is doing the data processing, and then you can process the data. For more complex scenarios, you probably want to use a shared Hive Metastore backend. In that case, then you would want a persistent metadata store somewhere. Often people like to use Amazon RDS for this purpose. So to kind of summarize Altus feature sets of what we tried to really target for Cloudera Altus is that we wanted to be end-user focused. So we manage the cluster, or Altus, the product itself, manages the cluster, so you don't have to, makes it very job-oriented. So we have a job-first kind of a workflow in which we have now job submissions, API, and CLIs. We have workload troubleshooting capability that's coming in later this month that is basically going to allow you to troubleshoot all of your jobs. So if you have issues with your data engineering jobs while your cluster is up and running, you can use Cloudera Manager, which has a rich monitoring and troubleshooting capability. When the cluster is terminated, we'll provide an additional type of workload troubleshooting capability so that you'll be able to troubleshoot as if your cluster were still live. We use cloud-native technologies, and this is the reason in order for you to get agility and lowest cost when running your cluster. So we decouple compute and storage. You spin up as much compute as you need in order to process the data that's coming in, and you terminate the cluster when you don't need it anymore. Spot instances support is coming shortly as well. We support per hour per node pricing, which is a usage-based consumption model typically found in cloud. The integrated platform is the no data silos approach with shared metadata across this data. And this applies to clusters, any type of CDH cluster that you have that is either deployed through Altus or deployed through any other mechanism. In security, we leverage AWS best practices, and then we also we are also planning to bring our security, basically our CDH security into the cloud as well. And there's an ease of use component. Aside from all of the job first workload troubleshooting and all of that, we've done some things to try to make it easy for the end user to run and troubleshoot their jobs. So I have a picture here of a high-level picture of what Cloudera Altus actually looks like, and then a demo that will follow. The Altus service architecture is such that we basically have Cloudera Altus hosted in blue in our environment, and this is the service provisioning layer itself. The orange is the AWS VPC of the customer environment. And so when you try to spin up a cluster, you would call the Cloudera Altus console or CLI, and you would spin up a cluster, and that cluster is in blue in this picture. And the reason it's blue is because Altus is managing that cluster in the customer environment. And the customer would then issue a job. The job is issued against the job API of Cloudera Altus or UI. The job gets queued onto the cluster. We have a job queue per cluster, and when there's capacity available, this job gets executed on the cluster. When the job is getting executed, all of the server log files as well as all of the workload log files are streamed and saved off onto AWS 3 for archiving so that you can troubleshoot all of your jobs after the cluster has terminated. Okay, and so with the remaining time, I'm going to do an Altus demo. And so what you'll see in this particular demo, the context of this is hospital mortality rates versus state GDP. So this is just the context of what the data is actually going to show. So in that context, we actually took raw data from Medicare.gov and from Wikipedia, that was the per capita state GDP, and then we just put this into S3 in raw data format. With Cloudera Altus, you can basically clean, merge, and filter all of this data into well-formatted data. And with this well-formatted data, we'll just show you with our Cloudera Data Science Workbench a visualization of this well-formatted data that has come out. So this is kind of a very common workflow in terms of ingest of data, cleaning and merging of this data, cleaning in the data engineering piece, and then using some analytic tool to look at this data or gain more insights into this data. Okay, so when you log into Cloudera Altus, this is the landing page for Cloudera Altus. So as you can see, you'll see things like what's new on the right-hand side, and it will have features, because we GA'd this. We GA'd this in April. We launched this 2 weeks ago at Strata London, and so it has some high-level description of what it is that we do, but you'll see more granular features coming in as time goes on. We also have the latest Cloudera Altus CLI, so you need the latest CLI in order to pick up the newest feature set, so you want to download the CLI. It's also in PyPy, so you can do a pip install as well. On the left-hand side, you can see a summary of your account information, so you can see things like the last jobs that were run, the clusters that you have access to that you can submit jobs against. So if I click on clusters, you can see all the clusters that are available to me that I have permissions to actually see. To create a Cloudera cluster, it's actually very simple. You can basically specify a name, you specify a service type, and here you can pick things like Hive, Hive MR2, Hive on Spark, Spark, and a couple of different versions of Spark. And then you select a particular environment. Environment maps into an AWS account to which you're actually provisioning. And typically, people segregate their AWS accounts by things like dev, test, prod, and you can basically have different environments in a single account that will deploy into the various AWS accounts that you have. Then you would specify the instance types for the worker nodes, and we have intelligent default configurations. So we already have done performance tests and have default configurations for these different instance types. That means that we've done some intelligent defaults in terms of allocating memory that goes to HDFS versus going to Yarn or to Spark itself. You need to specify a private key so that you can SSH into the cluster. And then there is a Cloudera Manager password that you would put in. So you can use Cloudera Manager in read-only mode. We don't allow admin mode because if you, we don't want you to admin the cluster. So we give Cloudera Manager access in read-only mode for monitoring and troubleshooting purposes while the cluster is live. So these are the only things that you need to specify, and then you can create a cluster. It takes about 10 minutes to create the cluster, whether it's a 10-node cluster or 100-node cluster. For the sake of time, I'm going to submit a job, basically against a cluster, and I can clone this job. So here I'm doing the hospital mortality rate versus state GDP, and I'm submitting a job. I can also submit a group of jobs. If I submit a group of jobs, then it will execute these jobs in sequence, and you can also opt to terminate if one of the jobs fails, so you don't execute the rest of the job group. But here I'm going to submit a single job, and I'll specify what application this is, where the jar file is located, and we use the S3A Hadoop connector. So the jar file itself is on S3, and then I specify an input and I specify an output directory for this particular application. And then I specify a cluster that I want to run it against. I already have an existing cluster, so here I'll submit the job. So if I just look inside AWS 3 console, I can actually see where the input is coming from. So where I can see I can see the program itself. I'm actually taking this jar file for the Medicare application. If I want to see where the input data is, I can see this in the input directory. The input directory is all the GDP and Medicare data in raw format that we ingested into S3. And when the data comes out, there will be an output directory here that will show where all of the clean data is. While this job is running, we do give the capability to take a look at this job in Cloudera Manager. So this is the standard Cloudera Manager interface. We provide a single CLI command so that it will create a proxy into your particular network, and then it will just pop up this screen on your browser, and then you can basically use Cloudera Manager as you would on-premise. So there's a single, this is the CLI for Cloudera Altus, and there's a single command line that should create this proxy, and I should be able to see Cloudera Manager. And then I just use the user password that I specified when I created the cluster. And I can use the same sort of monitoring interface here. You can see that the Spark job is running. You can click on these different links in order to see the log files and troubleshoot as you would on-premise. But basically, Cloudera Manager offers all of the troubleshooting capability links into the component UI, so you can see all of the individual log files. So this job will take about another 30 seconds. So the idea, again, is that we're submitting the job. The job resides on S3. Job is very simple to deploy. It's basically a first-class object within Altus, so you can see all of the jobs and all of the executions of these jobs that have been run. And Cloudera Manager, here you can see it actually finished running. And I'll go back to the Cloudera Altus UI. And I'll refresh this page. And you'll see that it's actually completed as well on Cloudera Altus. And if I look in S3, I can refresh the S3 page as well. You'll see basically the cleaned output here in the output directory. If I want to do some visualization on this, one option is to use basically this Cloudera Data Science Workbench, which we also released. I can create a new session for this. I think my old one expired, so I can launch a session in Cloudera Data Science Workbench. People will typically have some kind of visualization tools, and here you can see I'm taking the data using an AWS Python SDK, the Bodo 3 SDK, and I'm just pulling this data and visualizing with Cloudera Data Science Workbench. So Cloudera Data Science Workbench is our sort of interface for data scientists to do ad hoc queries and visualization of data into basically into CDH clusters. But in this case, we're just rendering this data that has been cleaned by Cloudera Altus. So here you can see all of the data that has been cleaned. Cloudera Data Science Workbench allows you also to share these projects with your colleagues and also provide URLs and things so that you can share all of the results that you've gotten through your visualization, and you can just share URLs that will basically show all of this results that came out of your data processing. Okay, so we're near the end. I just wanted to point out what the Altus resources are so that if you're interested in taking a look at Cloudera Altus, we do have publicly available documentation now that you should be able to read. We have a couple of blogs. There's an engineering blog that describes Cloudera Altus objects and workflows, and certainly contact our team if you're interested in hearing more. Thank you.